Welcome to English Learning Podcast, Throw Science.
Where we dig into your sources to pull out those key nuggets of knowledge. Today, we're jumping straight into something pretty mind-bending. Time travel. It's one of those ideas, isn't it? It feels both really futuristic, but also kind of philosophical. Honestly, it just grabs everyone's imagination. But here's the thing. This isn't just about sci-fi flicks. In this deep dive, we're actually looking at the real science, the physics behind it. What does it really say is possible? And, maybe more importantly, what isn't?
Exactly. And our mission today is basically to walk you through the source material. We'll start with, what is time travel, really? Then we'll get into Einstein's big ideas, which are crucial here. We'll have to tackle some pretty baffling paradoxes, too. And then look at how this whole concept shows up in science and, culture.
Yeah, and like always, we're aiming for this deep dive to be your shortcut to being properly clued in. We'll distill the most important bits of insight for you, hopefully, in a way that's, engaging. So, yeah, let's get started. First things first, maybe the basic question. When we say time travel, what are we actually talking about? What's the definition?
Right. So at its simplest, time travel is just moving between different points in time, like how we move around in space. Same idea, but with time. And yeah, it's huge in science fiction, obviously. But what's really fascinating is that it's not just fiction. It actually has real roots in physics.
And that's where it gets super interesting, right? Okay. Because the science behind this seemingly crazy idea, it might genuinely surprise you. All right, let's unpack this a bit. The absolute foundation for understanding time travel, scientifically anyway, comes down to Albert Einstein, specifically his theory of relativity. It's this theory that, kind of surprisingly, suggests some types of time travel are, maybe possible, theoretically at least.
Precisely. According to Einstein, time isn't this absolute constant thing. It's not like some universal clock ticking the same everywhere for everyone. Instead, it's actually flexible. It can speed up or slow down. And that depends on things like how fast you're moving or how close you are to something really massive like a planet or even a black hole.
Right. And this flexibility, this variable nature of time, it leads directly to something called time dilation. So what does that actually mean in practice?
All right, well, imagine you're zipping off in a spaceship, and you're going super fast, like almost the speed of light. Now, for you on the ship, everything feels normal. Your watch ticks normally, you age normally, But for people watching back on Earth, they'd see your time moving much, much slower. So let's say you go on a trip that feels like a few years to you. When you come back, decades might have passed on Earth. You've effectively traveled into their future.
And that's not just a thought experiment. That's real science, by the way. Astronauts up on the International Space Station whipping around the Earth really fast. They actually experience time just a tiny bit slower than we do down here. It's a minuscule effect, but we can measure it. It proves the theory. Actually, this whole effect is super important for things like GPS satellites to even work accurately. So every time you use maps on your phone, you're kind of benefiting from relativity.
It's pretty amazing when you think about it. And that's exactly why most scientists are generally okay with the idea that traveling forward in time into the future is, possible, at least in theory. You're essentially just letting Earth's time race ahead while yours goes slower, or just traveling forward at a different rate.
Okay, let's quickly recap those key ideas for everyone listening. Relativity, that's Einstein's big theory connecting space and time. Time dilation, the idea that time speed can change based on speed or gravity. And a massive object just means something really heavy, like a planet or black hole, that affects time nearby. So, think about this. Because of time dilation, those astronauts really do age just a fraction slower in space. Mind-bending stuff. Right. So, we've tackled forward time travel. I think it's scientifically plausible, if weird. But what about going the other way, going back in time? Can we visit the past? Now that, I imagine, is where things get much, much trickier.
Oh, absolutely. That's where you slam right into problems. The classic one everyone talks about is the grandfather paradox. It's the ultimate what if, isn't it? Think about it. What if you could go back in time, find your grandfather before you met your grandmother, and somehow, prevent them from meeting? If you did that, your parents wouldn't be born, which means you wouldn't be born. So how could you have gone back in time in the first place?
Whoa, it's a complete loop that just breaks logic. It doesn't make sense. And that kind of paradox, that knot, it really highlights why going backward in time might just be impossible. Or, if it were possible, incredibly risky for the timeline itself. Reality even.
Exactly. The future seems kind of open, theoretically, but the past, that looks pretty locked down by comparison. However, There are some really speculative, purely theoretical ideas about backward travel mentioned in the sources. But, take these with a huge grain of salt, like wormhole.
Ah, yes, the sci-fi favorite.
Right. Hypothetical tunnels, basically shortcuts through space-time, maybe connecting different places, maybe different times. But I mean, we are absolutely nowhere near actually finding one, let alone using it. It's pure math for now.
Okay, so wormholes are one idea. Anything else?
Well, there's also some thought around rotating black holes. Some theories suggest that the intense gravity and spin could warp space-time so much they might create these closed time-like curves.
Closed time-like curves.
Yeah, basically paths that loop back on themselves in time. So, theoretically, you could follow one back to your own past. But again, it's all theory. And getting anywhere near a black hole, rotating or not, let's just say it's probably not a good idea. Extremely dangerous doesn't even cover it.
Wow. It's still wild to think about how these extreme cosmic objects might bend the rules we take for granted.
Yeah.
And stepping back a bit, thinking about this stuff, it connects to broader ideas about time itself, doesn't it?
Definitely. It brings up things like the arrow of time. Why do we remember the past but not the future? It seems like a fundamental rule. A lot of physicists think it's tied to entropy, the idea that things in the universe tend to go from order to disorder. Like a broken glass doesn't just magically put itself back together, right?
Right.
That one-way street of increasing disorder might be what gives time its direction, making going backwards fundamentally problematic for how the universe works.
Which also ties into ideas like causality, cause and effect, and
Yeah.
the butterfly effect, right? I mean, imagine changing just one tiny thing in the past. The potential ripple effects down the line, they could be massive, unpredictable, catastrophic even.
Exactly. It's a huge can of worms. And it even connects to real science, looking into how we perceive time. Researchers study how our brains build our sense of time passing, which isn't always constant, It can change depending on emotions, focus, even certain substances. Our subjective experience of time is complex too.
And considering all that, it leads to some pretty deep ethical questions, doesn't it? Let's say we could change the past. Should we? Like, is it okay to try and fix a historical mistake if you risk completely messing up the present in ways you can't even imagine? What gives anyone the right? That's some serious power to think about. Okay, maybe let's shift focus slightly, away from the pure physics and philosophy for a moment. Because obviously, time travel is everywhere in pop culture. Movies, books, things like Back to the Future, Interstellar, Avengers, Endgame, they all play with it.
Yeah, and what's interesting is how differently they handle it. Some stories, maybe like Interstellar, really try to lean into the actual science, using relativity and time dilation as major plot points. Others, maybe more like Back to the Future, they just kind of have fun with it, right? They embrace the paradoxes and use them for laughs or drama. They don't get too bogged down in whether it really makes sense.
Yeah, true. But either way, scientifically accurate or not, time travel is just this incredibly powerful tool for storytelling, isn't it? It lets us explore big ideas, destiny, choices, consequences in really engaging ways. It taps right into our imagination.
Well, this has been quite a trip through science and imagination. Hopefully you're feeling pretty well informed now, maybe even had your mind bent a little.
Yeah, we've covered quite a bit from, the actual theoretical possibility of going forward in time using time dilation to the massive paradoxes and problems with going backward. And those bigger questions it raises about, well, reality, cause and effect, how we even experience time. It really is amazing how science and imagination can feed into each other like this, pushing at the edges of what we think is possible. We definitely encourage you to keep mulling over these ideas.
And maybe here's one last thought to leave you with, something to chew on. We remember the past, right? But we can't remember the future. Now, if traveling to the past was actually possible, what might we be overlooking about the value or even the beauty of time only flowing one way for us? What complexities are hidden in that irreversibility that we just take for granted?